All right, this is video number 4 on the intermediate value theorem. If f is continuous on the closed interval ab and k is any number between f of a and f of b, there's at least one number c in the interval from a to b such that f of c is k. All right, so this is some more complex wording for a relatively straightforward concept. So it's saying f is continuous on the closed interval AB. These are our x coordinates, or our x, the x we're looking at, the interval. So on the interval AB. All right. Now, k is any number between f of a and f of b. So f of a is the y value at a. And then f of b is the y value at b. All right, so that's right up here. All right, it's just the same. Now, it's saying that we have some type of continuous function. So f is continuous on this interval, and these are our output values. So if it's continuous, I'm going to go ahead and draw a continuous graph between our points. All right, here it is continuous. Now it says, so we met our criteria. We said f is continuous. We have a closed interval, AB. Here we have f of a and f of b, all right, our output values. It says there is at least one number c in AB such that f of c equals k. All right, so all that's saying is if I want to find a specific y value and I call it k, all right, if our function is continuous on this interval, there has to be an x value c so that goes with that y value. So it's basically saying if I have one value, it's saying that if I have a continuous function, all right, and my y values are between this range over this interval for x, there has to be another y value in that range that you pass through. So a lot of times where you'll see applications of this is you'll have to show that a function has a zero. So for example, all right, the intermediate value theorem. Use the intermediate value theorem to show the polynomial function f of x equals x cubed plus 2x minus 1 has a 0 on the interval 0, 1. Let's pull up the intermediate value theorem again. So the first thing we got to do is show that f is continuous. All right, now, if f is going to be continuous, all right, let's go ahead and get started for step 1. All right, in general, this is what these are going to be the steps for the intermediate value theorem. All right, we're going to check that our function is continuous. All right, so this is my function f of x, all right, equals x cubed plus 2x minus 1. Well, we're checking that it's continuous on that interval. Well, yes, it's continuous. This is a cubic function. All cubic functions are continuous. F of x is continuous because it's a polynomial function. All right, it's a cubic function. All right, so we met the first criteria. We can check off that it's continuous. All right, second, we got to check that we actually have y values here. All right, so we're going to find the function values. At the endpoints of our intervals. So I got, or at the ends of our interval, so I have 0, 1. All right, and it's closed. So I'm going to go ahead and find f of 0 and plug it in. That's 0 cubed plus 2 times 0 minus 1 That's -1. All right, now, next I'm going to find f of 1. That's 1 cubed minus 2 times 1 minus 1. That's also going to, or that's going to equal, or did I mess up? That should be plus 2 times 1. So 1 plus 2 minus 1, and we get 2. All right, now, we check that our function is continuous. We check the endpoints of the intervals. So this is a different theorem than when we're checking for continuity. All right, so now what we're going to do is I'm just going to graph to get a visual for step 3. All right, we have 1, 2, 3, 4, 5. All right, so I'm going to go ahead and graph 0, -1. That is right here. I'm going to go ahead and graph 1, 2. That's right here. Now, it's saying that we want to show that this function has a 0 on this interval. Well, we know it's continuous, so that means that I'm going to be able to like connect this part of my graph to the other part of the graph. All right. So now we're able to see now that because it's continuous, there's got to be at least one point or 1, 0 that we have on this interval. So now what I'm going to do is I actually have to state some stuff. Now I notice that f of 0 is -1, it's less than 0, and f of 1, that's 2, is greater than 0. So by the intermediate value theorem, there's some number C in 0, 1 such that f of C equals 0. In other words, I showed on this interval I had 1 point below the x-axis, 1 point above x-axis, so the function has to pass through x-axis if it's continuous on that interval. So this is just saying if you have a point above the x-axis, you have a point above the x-axis on a certain interval, and your function's continuous, you have to have a 0 because it has to be able to pass through to get from one point to the next. All right, so 1 point below, 1 point above. If it's continuous, your points are going to be connected, and you have to be able to have a 0.